Good morning, one and all. In this video lecture, I would like to discuss about the concept called universal shift register. So, universal shift register is consisting of multiplexers and as well as flip-flops also. The name it is indicating that universal shift register. So, therefore, it is doing the operations, four operations. One is shift right, one is shift left, and parallel loading, and the previous state, which is nothing but memory state, is also which is doing. So, this is called we can call universal shift register. Now, in this universal shift register, let us observe this particular circuit diagram. My input pins are connected to the third pin of the multiplexer. So I3, I2, I1, I0, and second pin is connected to the A2 here. A2, the output, parallel output A2 is connected to the second pin, and first pin is connected to the serial input for shift right, and zeroth pin is connected to the A3. In the similar way, here second pin is connected to the A1, and first pin is connected to this A3, and then zeroth pin is connected to the A2, and third pin is connected to the I1, and second pin is connected to the A0, and first pin is connected to this particular A2, and then zeroth pin is connected to the A1. Like we connected the each and every multiplexer with respect to get the some output, and multiplexer output is connected to the each flip-flop D, and we have a 4 is to 1 multiplexer. It means that we need to have two selection lines. My two selection lines are S1 and S0. So this is based on the mode control. We defined what is happening when S1 is 0 and S0 is also 0. It means that no change state will occur, and 0 1 means shift right, and 1 0 means shift left. 1 1 means parallel load will occur. So initially I will explain first case as parallel mode. So this is what I will explain now. Let us have a look. Now my inputs are, let us consider. Again, I would like to consider my inputs are 4 ones. Say for an example, I am considering, you can choose any value. 4 ones. My mode of consideration is here S1 is 1 and S0 is 1. So for a multiplexer, my input is 1 1. It means that third pin is connected here, and third pin is connected to the multiplexer internally, and third pin is connected, and then third pin is connected for each multiplexer. Now third pin, my input is I3, that is my input as 1. So this 1 is moving in this direction, and 1 as an input for this particular D flip flop. So 1 as an input means obviously you will get your output as 1 for the flip flop, and here my input is 1, again you will get your output as 1, and 1 is my input, you will get your output as 1, and 1 is my input, you will get your output as 1. So this is what parallel loading. So simultaneously you will get your data at the final output. So this is what parallel load. So 1 1 case. And if you go for another case, 1 0 consideration, so I will show you the 1 0 consideration. Yeah, if you observe 1 0 consideration, so it is showing that shift left. So I am giving my input as here for a multiplexer 1 0. Therefore 1 0 means second pin is connected. Second pin is connected for each multiplexer. Now for the second input pin, here in this particular we don't have any input, we don't have any input, we don't have an input means you consider at this particular point. So your input is given here, so it means that your input is going in this direction. So say for example I would like to give again 4 ones is my input. So initially my least significant bit 1 is moving here. So 1 1 and 1. So 1 is moving here, and then 1, you will get your output as here 1. Now this is connected to the next multiplexer second pin. So this is coming in this direction. I am showing with you red color line. Now this is connected here, and then my input, say for example it is 1, and you will get your output as 1, say for example. Now again it is connected to the next multiplexer second pin, and then it is moving in this direction, and then you will get your output, say for example 0, and it is connected to the next multiplexer, so for the second pin, and then it is connected your input is 0 and you will get your output as 0. Here also your input is 0 means you will get your output as 0, like it is connected. So here you can observe that shifting of left side is occurring from each flip-flop to another flip-flop. Therefore left shift of each bit is going on. Therefore shift left operation will exist at this particular phenomenon when S1 is 1 and S0 is equals to 0. Now we'll move to the third condition. So in third condition, my input is 0 and 1. 0 and 1. So this is what my third condition. 0 1. So in 0 1 means first pin is connected for each multiplexer. 0 1 means first pin is connected for each multiplexer. Now, for this first pin, I am giving my input here serial shift right. So again, I will give my 4 digits of information. In that least significant bit, 1 is connected. So now this 1 is going here, and then your input for the flip flop is 1. You will get your output as 1. Now this is connected to the next multiplexer at the first position. Now 1 input and again 1. You will get your output as 1, and then it is connected to the next multiplexer, and then say for example your input is 0 here, and then you will get your output as 0, and then it is connected to the next multiplexer for the first pin, and then you will get your output while simultaneously. Therefore here you can observe that my multiplexer output is connected to the flip flop, to the next flip flop, and then to the next flip flop, and then to the next flip flop. So here you can observe that shift right operation is going on. So when 0 1 condition is existing means shift right is going on. So and finally the fourth condition is 0 0 consideration. In 0 0 consideration, 0th pin will be selected. 0th pin will be selected. I am showing you 0th pin is connected. 0th pin, and then 0th pin, and then 0th pin. Now for this 0th pin, what my statement here, no change state is here. Say for example 1011 is my previous state output. This is my previous state output. So now you need to check your next state output. So previous state as one of the input in the sequential circuit. Now this one is here coming again here, and then it is moving here, and then end. So now 1 as an input, you will get your output as 1 here. Okay. Now in this particular case, 0 is going 0 0 0, and then 0 0 is my input. You will get your output as 0. Okay, and your input is 1 here. This is my previous state is connected to my multiplexer, and it is connected to my flip flop, so therefore my output is 1. And then this one, in the same case you will connect it to the 1 as my input, you will get your output as 1. So this is my next state. It is similar to 1011 of my previous state. Therefore no change state is occurring when the fourth condition 0 0 condition. So this is what universal shift register. In universal shift register, both the four chances here, one is no change, one is shift right, shift left, and parallel load, which is based on the mode of selection of my multiplexer. So completely it is dependent on the mode of my selection. So we can conclude this universal shift register with this. And thank you.